Okay, so let's turn to the fifth problem, which is a paired sample t-test. And so 4 statistics students were randomly selected for a tutoring program after the midterm exam. The tutoring program lasts until the final. Below table summarizes the grades before and after the tutoring program. Test the following hypothesis at an alpha of 0.05. Okay, so this null hypothesis states that the final minus the midterm is less than or equal to 0, and the alternative is that the final minus midterm average is greater than 0. Okay, so the first question is, what kind of a hypothesis is stated? Is it a one-tailed or a two-tailed? And that is, of course, a one-tailed test. Do we work with a t-score or a z-score? Well, if we look at the data that we have, we don't know anything about the population, so we have to work with a sample standard deviation, so that is clearly a t-score case. So what is your critical t-score? So what we need to do is we need to first calculate the difference between the final and the midterm. So we can do that manually. So this would be a 6. Then here somebody got actually worse by 1. So what I do is final minus midterm. Then here somebody got better by 8. And here somebody got better by 7. But let's just copy that into Excel because we need more information. So let's put our data into Excel. And then let's just calculate final minus midterm. And let's just quickly copy again the same format. Okay. So what we need is the average for each. So before the tutoring program, the average was 75. And after the tutoring program, the average seems to go up. That should be equal to the difference. So here we should also see a positive 5. And then what we do is we just calculate the standard deviation for the difference. So we don't have to calculate that really for the midterm and the final. What matters is this column now. So the standard deviation is equal to the standard deviation sample. So on the difference, we have a standard deviation of 4.02, so that means that the standard error associated with those differences is equal, let's just copy the format, is equal to the sample standard deviation divided by the square root of 4. So now we have a standard error of 2.041, and we have degrees of freedom of 3. Okay, so now if we solve this problem, what's all the information that we have? So we know n is 4, and then that means degrees of freedom 3. Our sample average is a plus 5. And that is the average of final minus midterm, and the standard error is 2.041. Okay, so what we do in this hypothesis test is we assume that there was no difference. So the hypothesized final minus midterm, I call it now F minus M, that average is supposed to be 0, but it turns out that we got a, so this is the mean, but our actual F minus M is a positive 5. So now we want to know how many standard errors is that away from a hypothetical mean of 0. So that will be our test statistic. So our T test stat is 5, our average, minus the hypothetical mean of 0, divided by the standard error of 2.0141. So that means our test statistic is equal to the difference of the 5 divided by the standard error. So it's 2.449. So that's our test statistic. So the 5 is 2.449 standard errors above the mean of 0. So we have a one-tailed test. So the question is, what is the critical T? So the T critical okay, so in a one-tailed test we need to find the area to we need to find the t-score to the left of which we have 5% probability mass. So that's the T critical. And for this we use the T inverse formula. T inverse, open the probability, because it's a one-tailed test, 0.05. We have only 3 degrees of freedom. So now we get negative 2.353, but actually if you look at this little diagram that I just drew, we definitely need the positive value of that, so I put an absolute around it. Okay, so this problem translates into a T. So here we had the grades difference, and here we convert everything into a t-score. And we know that our critical T is 2.353, so maybe that's here. This is our T critical, 2.353, but our actual t-score, the one that corresponds to the 5, our test statistic, maybe I should do that in a different color. So this one here, we can see this is clearly in the rejection zone, 2.449. Because our rejection zone starts next to the critical T, so this is the rejection zone. So our test statistic falls into the rejection zone. And what is your critical T or C score? So the critical T is equal to 2.353. And what is your test statistic? That's the 2.449. T-test 2.449. And then we said, of course, we will reject the null. What do you conclude? So we reject the null. Reject H0. But what's the probability that we made a type 1 error? Well, the remaining uncertainty is that we need to find this area to the right. That is the p-value. The probability that we made a type 1 error, p-value. And this is the area to the right of our test statistic. So we will do t dot dist, open parentheses, and because I need the area to the right of 2.449, I can say minus, and then I click into the cell where you see the 2.449, it makes it negative. I still have 3 degrees of freedom, and I want it to be cumulatively, so comma 1, close parentheses. And of course we need to have a probability of less than 5%, and we get 4.6%. So the probability that we made a type 1 error is p equals 0.046. Okay, so now let's see what we get if we let Excel do everything. So now we go to data analysis, and we go to a t-test paired to sample for means. My data will have labels, and I first highlight the data for the final, because Excel will then subtract the variable 2 range, that's the midterm, so this way I get a positive difference between final and midterm, which corresponds to the positive 5. Then the hypothesized mean difference is 0, and yeah, that is what we had in the problem set 2. And so the output range, I put it here so we can see it next to the calculations that we did. Just say OK. So, okay, let's limit everything to 3. Okay. Okay, so here we see we have 3 degrees of freedom, and because we specified it as a one-tail test, that critical in a one-tail test is the 2.353, which is also what we got. Our test statistic is 2.449, you see that here, and our probability that we made a type 1 error is 0.046, which you also see here. But of course Excel will also give you the result, assuming that we had a two-tail test, but that's not the case here. But what Excel will not give you is the standard error that we used in order to calculate the t-stat. And so that's why it's always good not to rely exclusively on Excel, but also to know what Excel is basically doing in the back of its various calculations. But anyhow, that was a pretty simple paired t-test, and yeah, let's just stop here, and then the next video let's take a look at another problem.